thin line. Let me take it. Yeah. No. Let me take the equal displacements. What is these are the equal displacements, delta S, or I'll increase the size. Delta H will take it. So what about the time intervals to descend this particular one? So there is some ball. I'll release it from here. Some color. Okay, here this one. So it is going to pass through this particular positions. Then what about the time interval I'm asking? So what can be the time interval? This time interval will be delta T1, delta T2, delta T3. In uniform excited motion, the time taken to have equal displacements will decrease. Delta T3 will be less than delta T2, less than delta T1. Okay. Or we'll go for one more. Okay, this is for this particular situation. Okay, now similarly, I'll bring another. Just now we discussed that. I'm trying to conclude here. Let's take this one. I'll release this object from rest. There's a particle, I'll release it. For equal time intervals, we'll take it now. Just now, previously what we discussed, that only for equal time intervals. Delta H1, delta H2. What about the time interval? They are same. Then the distance covered, the displacement will increase because the reason for that, because of gravity. Because the gravity will produce that acceleration. So what is the conclusion we can make it? In uniform excited motion, the time taken for equal displacements will decrease Similarly, in equal intervals of time, the displacement of object will increase. Now, what should happen to the average velocity with the help of this? We can compare. So the average velocity should increase as it descends. There's a body or a ball, you can write it. Or you can throw any stone, something, you release it from rest. Ball, release from rest. And what about it? There's a basic motion that it takes place here. So therefore, what are the conclusions we can make it here? Now, regarding velocity is what we can see. The velocity will keep on going to increase here. For a freely falling object. For a freely falling object. Or a body, for a freely falling body or particle, anything you can write it. Or an object, anything. So what is the first thing like? Displacements. So first point here, like and all. The time taken for equal displacements will decrease. The time taken for successive equal displacement. Successive equal displacements will decrease. Next again. For equal intervals of time, the successive displacements will increase. the successive displacements will, for equal intervals of time, the successive displacements will increase. Okay, there's one thing. Anything can we say about average velocity? Average velocity will increase with time or as it descends. So what is the basic idea for this? Average velocity should be equal to v of t dt 0 to t. So what is v of t? So v should be equal to gt. Ball release from rest at t equal to 0. There's assumption. So what is the expression for velocity of the ball at any time t given by this one? So substitute this here, gt dt. Integral of this will be t. For any interval of time you can pick up. So this will become g solving this will get average velocity is equal to gt by 2. So look at the average velocity, it is going to increase with the time. So can we go for any plots? Once again, I'm going to bring all the plots here. For a freely falling body. Once again, we'll bring all the plots at one place. Oh, to shift this down. Let's compare all the curves. What about the position versus time? So height descended curve will be like this. So what about the velocity? It will be a straight line passing through origin. What about the average velocity? It will also linearly, it will come. Okay, this is for freely falling object here. So again, in the graph also you can analyze all the things. So this is about the overall picture about for a freely falling object, the average velocity will increase with the time. Then what about the distance covered in nth second here? Any formulas? I think let me dump all the things here only. Distance covered for in nth second. Or displacement in nth second, distance or the distance covered in nth second. So there should be equal to Sn u plus g by 2n minus 1. N is nth second. So what is the height descended, distance covered or height descended? Anything you can put it here. Distance means here vertical distance. Vertical distance covered in nth second is given by this particular formula. If it is released from rest, put u0. If it is projected with certain velocity, take help of this u. Instead of a, g will come into picture. It is about the freely falling. Okay, next we'll go for vertically projected.